Okay, this was the first one that was missed the most. Two terms. There is a GCF here of 2. That leaves you x squared minus 16, which by now we should know is a difference of squares. If you don't know what a difference of squares is by now, I mean, forget about good or bad. It's just I don't know what else I can do to show you now. Like if you don't know by now that you shouldn't be wearing a hoodie in class, that's also, I don't know. Luisi, can you take the hoodie off, please? Muy amable, gracias. Sean's gonna do it. So a difference of squares looks like it's conjugates in factor form. This is x plus 4, x minus 4. You should know what conjugates are by now also. Since this was from the practice test, when you go back to the practice test and you would find the box that had a 2 on it, you would check that box. Okay? You would find the box that had an x plus 4, you would check that box, and then the x minus 4. There were 3 boxes that are checked. That's why on the top it says select all that apply. It has 3 factors. That's what you would select. Here we have 3 terms. But how can I tell just by looking at this? Without even thinking. Like I'm not even going to ask you what it is, but how can I tell just by looking at this quickly that those 3 terms have a common factor? That they have to have a common factor. Just look at it, bam, and I know that they have a common factor. They're all even. They're all even. So I know at least 2 goes into all of them. But now, yes, when you start thinking more about it, there's more than just 2. There's actually 4. I can divide all of those by 4. And when I do that, I bring out the 4. That leaves me 3x squared minus 2x minus 8. And then now, A is 3, B is negative 2, and C is negative 8. So we got negative 24. 24 is 124, 212, 3, 8, 4, 6. Under this scenario, the smaller one becomes positive, the bigger one becomes negative, so the 1 and 1 is that one. But A wasn't 1, A was 3, so I gotta stick that 3 in front. I can't forget about the 4. Sadly, yeah, the entire problem would have been marked wrong if you would have forgotten the 4. So that 4 has to still be there. But then for now, put that 3 in front, so 3x plus 4 and 3x minus 6. The 4 still drops, the 3x plus 4 can't be divided by anything else, but the 3x minus 6 can be divided by 3, that leaves you x minus 2. On the practice test, you would then check the box around a 4, check the box around 3x plus 4, check the box around 3x minus 2. There should be 3 boxes that are checked off. You have any questions? Say something. Just because I'm going fast, don't think I'm not taking questions or anything. Have any questions? You don't know how I got a certain number, let me know. The real test is tomorrow. This was also, again, nothing here was correct more than like 27% of the time. I don't get it here. Because here A is 1. So watch, let's see if we can do this one mentally. Can anybody think mentally of 2 numbers that multiply to give you negative 18 and add up to negative 7? Without even doing a table, can you think of 2 numbers that multiply to give you negative 18 and add up to negative 7? Well, close. It does involve a 9 and a 2, but one of them has to be negative. The 9 has to be negative. The 2 would be positive, so this would just be y minus 9, y plus 2. You would go and check. I mean, like the way it would look would be a box, and one of them has a y minus 9 next to it, one of them has a y plus 2, and you would just check those boxes. Everything else you leave without a check. That one only has 2 factors. Okay, this one's a little bit more challenging because A is not 1. There's also no GCF. So here A is 3, B is 10, C is -8, -24, and 10. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Under this scenario, negative, 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 positive, positive, positive. The one that gives me 10 is -2 and 12. But since A isn't 1, I have to write 3A minus 2, 3A plus 12. I'm getting this -2 and this 12 from the table. If I have anything in common, I have to reduce them. I can't do anything with 3A minus 2, but this last one can be divided by 3, which gives me A plus 4. So those would be the 2 boxes that you would check, the 3A minus 2 and the A plus 4. If you're not sure how I got something, say it. I'm not trying to get through everything, but I'm willing to stop if you have questions. Here's another one where, and on Monday we spent most of Monday dealing with these with trinomials that had an A that was greater than 1. So 2 and -15 is -30. B is 1 and 30, 2 and 15, 3 and 10. If you can do it in your head, you don't have to do all this stuff. Just a way of, if you can't do it in your head, get a calculator, just 30 divided by 1, 30 divided by 2, 30 divided by 3, 30 divided by 4, 30 divided by 5. Try to see what, as long as you don't get a decimal, then you can write down the pair. Under this scenario, negative, 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 positive, 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 and the one that gives me what I want is there. There was no GCF, but I have to write the 2. I have to write this 2 in front. That's the shortcut I showed you. 2x minus 5, 2x plus 6. I can't do anything with the 2x minus 5, so that just drops. But these can be divided by 2, so that gives me x plus 3. So the 2 boxes I would check. I had one person that almost got a perfect paper. I think I had 1 minus 1 yesterday on the practice test. But other than that, it wasn't too much. Yeah. Why did I put the 2 in front? Because anytime that A is not 1, you can't just say x minus 5 and x plus 6, because if you multiply those, you're not going to get what you started with. So really, like the way it's supposed to be taught, the way I used to teach it, was to get the original expression, and what you're supposed to do is get these 2 numbers and use them to split the middle term. We've talked about how like factoring is the opposite of simplifying. Instead of combining like terms, you would like uncombine that x in the middle and turn that x into a negative 5x and a plus 6x, and then do a process called grouping. But I had such little success, and not just me, other people also. Grouping would look like this, where you bring out an x, this leaves me 2x minus 5. Here I bring out a 3, that leaves me 2x minus 5. And since both of these match, then I can do inside times outside, and I get the same thing. That's the way it should be taught. I had very few people that understood it, so I kind of eventually over the years just gave in and went with this shortcut. But just understand that it's a shortcut. Like, you definitely can't do this because that doesn't give you what you started with. But you also, even by just putting the 2 in front, you also can't leave it this way because, again, it won't give you what you started with. If you multiply these 2 times each other, you won't get that. You can tell this by looking at it. What's 2 times 2? 4. Like, you're not going to get what you started with. But as long as you can remember to look for a common factor. Can I divide 2 and 5 by the same number? No, so you just drop it down. Can you divide 2 and 6 by the same number? Yeah, by 2. So as long as you can remember to do that and divide each one, now if I multiply these two down here, I will get what I started with. What's 2x times x? 2x squared. 2x times 3 is 6x, but then negative 5x, negative 5 times x is negative 5x. When I combine those two, what is 6x minus 5x? 1x, which is that up here. And then finally, what's negative 5 times 3? So this is kind of a shortcut that I've started to use now. Like if you've been with other teachers before and they teach you this X method thing for factoring, it's kind of the same thing that I'm doing. It's just showing it a different way. I like doing it this way because it incorporates this table so that the people that are not strong with mental math at least have a method that they can try to follow. Whereas from what I can tell, this X method relies heavily on mental math. Here we do have a GCF. Trayshawn, what number can I divide all three of those terms by? By 5. So you bring out the 5 first. Divide everything by 5. That leaves me x squared minus 7x plus 6. The nice thing about that is now the leftovers, there's a 1 in front. So now, Trayshawn, I'm going to be able to go straight to factored form. When I do 1 times 6 and then negative 7, I'm going to end up with negative 1 and negative 1 and negative 6. That's going to give me what I want. Well, now because A was 1, I could just write, x minus 1 and x minus 6. But what I also can't forget is that I had this 5 in front. I was only able to do this because I took that 5 out, so that 5 needs to stay in front. So if you're taking the retake, you would click the 5, click the x minus 1, the x minus 6. There's 3 factors there. Okay, so Trayshawn, watch. Here, now we're back to one where the A is not 1, so we're going to have to do those extra steps. There's no greatest common factor here. So now the nice thing about this one is that at least everything is positive. So you're less likely to make a mistake with sign. 6 times 2 is 12, 7. Can we do this without writing everything down? Can you think of two numbers in your head that multiply to give you 12 and add up to 7? 3 and 4. Shouldn't be too difficult. 3 and 4. But Trey, because A was not 1, now we'll use that little shortcut where we'll write 6x instead of writing x plus 3. I'll write 6x plus 3 and 6x plus 4. But you have to know to reduce those. What's the biggest number I can divide 6 and 3 by? By 3. What's the biggest number I can divide 6 and 4 by? Divided by 2. So this gives you 3x plus 1. This gives you 3x plus 2. Now if I, actually wait, no, this is wrong. Sorry, this should be a 2. Did you get it? No, I made a mistake. 6x divided by 3 is 2x. So now if I were to multiply these two, I would get what I started with. This one was, I could look it up, but again, nothing on yesterday's practice test was correct more than 27% of the time, including this one. You should be able to tell just by looking at it that this is a difference of squares. Difference means subtraction. Squares means that we have two perfect squares. 3x times 3x is 9x squared. 2 times 2 is 4. You do not have to write that step, but you do have to know that when you write your conjugates, it's 3x plus 2 and 3x minus 2. The mistake a lot of people would make here, if they're being lazy about it, is write 9x plus 4 and 9x minus 4. You have to write the square roots. So when I go check the boxes, these are the boxes I would check. Required here. If you multiply these two, you end up getting that. Okay. The thing about this one, okay, the numbers are a little bit bigger. There's no GCF, but the good thing about this is that everything is positive. Let's see if somebody not named Diana can do this in their head. Can we think of two numbers that multiply to give us 45 and add up to 18? So at least everything's positive, right? So can you think of that without having to write everything down? Two numbers that multiply to give you 45, add up to 18? No, 9 and 5, when you add that gives you 14. 2 times 5 is... Okay, so then let's write them down then. 1 and 45, 3 and 15, and 5 and 9. Under this scenario, everything would be positive. Which one gives me 18? But look, because A was not 1, I have to go through that little process where I write 5x plus 3 and 5x plus 15. 5 and 3 can't be divided by the same number, so that just drops. 5 and 15 can't be divided by 5, so that gives me x plus 3. Those would be the two boxes you would check. You would check the box next to 5x plus 3, you would check the box next to x plus 3. Here we have no GCF, and there is a negative, so there's two negatives. But as far as multiplying goes, 2 times negative 4 is negative 8. Another one's negative 7, but at least the numbers are small. The only numbers that multiply to give you 8 are 1 and 8 and 2 and 4. Under this scenario, I told you to make the bigger ones positive and the smaller ones negative. So that's what I want. That's what you need. But since A was not 1, you're going to write, instead of x, you write 2x. Instead of x, you write 2x. Trayshawn, what number comes next on each one? Plus 1, negative 8. Can't do anything with this, so this just drops. These can be divided by 2, so you get x minus 4. Those would be the two boxes that you would check. I could see where you would have messed these up on the quiz, because for the quiz, we covered it, but we didn't have a chance to do a lot of these where the lead was greater than 1. But on yesterday's practice test, we spent pretty much all of Monday doing this. Like, those were almost every single problem had that. Okay. Here we have again an A that's greater than 1, but there's also a GCF. Trayshawn, what can all those be divided by? By 2. So x squared plus 3x minus 10. I don't want to distribute, but if I were to distribute, I would get what I started with. So now when I factor the leftovers, at least A is 1. Here's another challenge. Can you think of, without having to do a table, can you think of two numbers that multiply to give you negative 10 and add up to positive 3? I don't mind if you can do it in your head, great. A lot of us can't do that in our head, but if you can. two numbers. I'm looking for two magic numbers. When you multiply these two numbers, you get negative 10. When you add them, you get positive 3. Well, it does involve a 5 and a 2, but one of them has to be negative. Which one is negative? 5 minus 2 is 2. So x plus 5, x minus 2. But then don't forget, that has to drop also. When you go back and take the practice test, and where I showed you that the link was, you have to check all three of those boxes. Okay, now start the equations. What do you see now that you haven't seen yet today? Huh? Equal sign. Okay, but not just like on the quiz that we went over. The only difference is that the first step is that you got to make this equal to 0. And then after that, pretty much, the majority of the work falls around the factoring. Look here, A is 1, right? So can you think of two numbers without doing a table? Two numbers that multiply to give you negative 4 and add up to positive 3. Diana? Can you think of two numbers that multiply to give you negative 4 and add up to positive 3? No, 1 and 3 is not going to multiply to give you 4. Positive 4 and negative 1. So x plus 4 is x minus 1. I can go straight to factor form because I had a 1 in front. So I don't have to do those extra steps. So now just make each one equal to 0. This is factor form. So remember those problems that started in factor form? Here we had to factor, but now make each factor equal to 0. X can be negative 4, x can be positive 1. Now there was one slight little difference on the practice test that you won't have it on the test tomorrow, but some of the practice test problems said the way it was phrased was like select any solution. So yeah, this equation has two different solutions, negative 4 and positive 1. If both of those are there, yeah, check both of them. But if only one of them is there, just check the one that's there. I think the way I did it was with a fraction. I think if there was a solution that was a fraction, I didn't write the fraction in. I only put the ones that were whole numbers. So, you know, that was a little bit different on the practice test, but that won't be the case on the test tomorrow. It's multiple choice. Okay, make this equal to 0. Minus 84 minus 28x minus 84 minus 28x. But I also want to write this in standard form. If you try to do a factor chart now, you're going to have a nightmare. Good news is if you follow directions, you won't have a nightmare. Because this has a GCF. What can all of these be divided by? By 7, yeah. And if you bring out a 7, not only does the A become 1, but it also makes your numbers much smaller. 12. Let's try this again. Can anybody think of two numbers that multiply to give you negative 12? Because since A is 1, I don't have to worry about that. Two numbers that multiply to give you negative 12 and add up to negative 4. You don't have to do it in your head, but we're just trying something different. Again, the phone again. Annalisa? You need me to hold it for you? You can put it away. Anybody can think of two numbers that multiply to give you negative 12? Negative 6, positive 2. There are three factors here, but since the 7 does not have a variable next to it, I can ignore it. The only things I have to make equal to 0 are x minus 6 and x plus 2. This gives me positive 6. This gives me. If both of those solutions are there on the practice test retake, check both of them. But if only one of them is there, just check the one that's there. I think on this one, both of them will be there because I mean, not that I had to tell you this, but I think the ones I left out were fractions. If they were fractions, I just didn't write them. All right, this one's a little bit more challenging because there is no GCF. So once I make it equal to 0, the number in front is going to be greater than 1. I'm going to have to do those extra steps. A is 5, B is 13, C is 8. At least everything is positive. So theoretically, maybe it wouldn't be too hard to do in your head. Can anybody think off the top of their head of two numbers that can multiply to give you 40 and add up to 13? I'll give you a hint. The numbers are already on the board. What two numbers multiply to give you 13 and add up to 4? Multiply to give you 4 and add up to 13. 5 and 8. If everything is positive, I think everything's going to be positive. But you can't forget to write that 5 in front. So 5x plus 5 and 5x plus 8. It's 5 that was in front came from that 5 there. The other numbers came from the table. And this was an equation equal to 0, so we keep it equal to 0. If there's anything in common, like these do, you're supposed to divide it out. So this gives you x plus 1, and this gives you 5x plus 8. So I can try to finish everything on time. I'll just do this quick. If I make these one equal to 0, this gives me negative 1. This gives me negative 8 over 5. So I'm pretty sure that when you go back and take the practice, those are both solutions. And if this was a free response test on paper and pencil, you'd have to write both of them. But when you go back, I'm pretty sure this is the only one that's going to be there. I don't think I wrote negative 8 over 5 there. Not because it's not a solution. I phrased the problem differently. I write any solutions that are there. So if the other one doesn't show up, just click the ones that do show up. Okay, this one here only has 2 terms, and it's already equal to 0. But if I factor out the 3 that's in common, look at what's left over. That's the difference of squares. That's the difference of squares. So that's x plus 5 and x minus 5. Those are your conjugates. There are 3 factors, but the only ones that have a variable are the x plus 5 and the x minus 5. So those are the ones that get made equal to 0. X can be negative 5, x can be positive 5. Those would be the ones that you go check. And on this one, I'm pretty sure both of them would be there. Okay, this one's not equal to 0. Don't do minus x squared because we don't want to end up with a negative in front of the x squared. So I'll move the other 2 terms the other way. So x squared plus x minus 20 equals 0. Since a is 1, like eventually somebody that like takes algebra 2, you should be able to do this in your head. Can you think of 2 numbers that multiply to give you negative 20 and add up to positive 1? It's positive 5 and negative 4. So when you make each one equal to 0, this one gives you negative 5, this one gives you positive 4. These would be the ones you select. 2 left. Even though this looks a little bit weird and confusing because it's quadratic, because this square is here, make it equal to 0 like any other equation. But when it comes time to factor, there's only one thing you can do here, and that's a GCF. What do both of those terms have in common? They both have an x too. So x minus 6. So now the GCF, Jade, does have an x. There is an x there. So even though it's on the outside, you still have to make that x equal to 0. And then when you make 7x minus 6 0, just to save time, this ends up giving you 6 over 7. On the practice test, I doubt the 6 over 7 would be there, but you could still click the x equals 0. They're both solutions. It's not like one solution is better than the other one. It's just that's the way I structured the test. Last one, and I will have now done 18 out of 22 problems for you, just giving you the answers. 2x squared plus 7x plus 6. Now here there is no GCF. So 2 times 6 is 12, and I have to add it to 7. The two numbers I want here are 3 and 4. But because there was a number greater than 1 there, I'd have to write 2x plus 3 and 2x plus 4, but just temporarily. That second one can be divided by 2. So 2x plus 3 and x plus 2 equals 0. When I make each one equal to 0, the first one gives me negative 3 over 2. The second one will end up giving me negative 2 when I solve. Both of those are solutions. On any test, you would be expected to include both of them. But on the practice test, I'm pretty sure that that's the only one I put. But if I'm wrong, just put anything that's there. All right, real test tomorrow.